Hey everyone, and welcome back to Summarize Science. Have you ever asked an AI a question, then rephrased it slightly and gotten a completely different or even wrong answer? It's a common problem, and it points to a major weakness in today's AI models. Take a look at this example from a new research paper. An AI is asked how many times the Earth rotates while orbiting the Sun, and it correctly says 365. But when the question is worded just a little differently, it suddenly answers 1, which is totally wrong. This inconsistency suggests that these models might not be truly understanding questions, but rather matching surface-level patterns they've memorized. To tackle this head-on, researchers developed a new benchmark, which is like a special exam for AIs, called RoParQ. They gathered thousands of questions from various standard tests. Then, they used other powerful AIs to create two paraphrased versions of each original question, ensuring the meaning stayed exactly the same. The key step was to specifically select the questions that consistently tripped up a judge AI, the ones where it would get some versions right and others wrong. This created a targeted stress test designed to expose an AI's inconsistency. But how do you measure this consistency with a single number? For that, they proposed a new metric called XParaCon, which stands for cross-paraphrase consistency. You don't need to understand the math, just know that it calculates a robustness score for a model. A higher XParaCon score means the AI is more stable and reliable when answering paraphrased questions. First, the researchers tested a bunch of existing models, from small open-source ones to massive proprietary ones like Claude 3.5 Sonnet. As you can see in this table, performance generally scales with size. Bigger models tend to be more accurate and more consistent. However, even the biggest models still showed gaps in their consistency, especially on tricky math reasoning problems. Interestingly, one smaller model, Quinn 3-4b, punched way above its weight, hinting that size isn't everything. This is where it gets really exciting. The researchers didn't just diagnose the problem, they created a solution. They used a special training method called paraphrase-aware fine-tuning. This is like giving the smaller AIs extra lessons where they are shown an original question and a paraphrase, and are explicitly taught to arrive at the same answer for both. The results were dramatic, as you can see in these charts. After this special training, the consistency scores of the smaller models shot up significantly. So, let's recap the important points. Large language models often fail when questions are rephrased, showing a lack of deep understanding. The researchers created a benchmark called RoParQ to test this weakness and a metric called XParaCon to score it. Most importantly, they showed that a targeted training strategy can make smaller, more efficient models just as robust as models that are vastly larger. What does this mean for the future? It suggests a path towards creating more reliable and trustworthy AI that doesn't just rely on brute force scale. We could see highly capable, efficient models that truly understand the meaning behind words, making them safer and more useful in the real world. That's all for this edition of Summarize Science. Thanks for watching.